So in this video, what we're going to start to do is we're going to look at how we can use the Y1 and the Y2 function on our calculator to solve some equations also. So if I go ahead and I look at this example, we have here, they don't give us the choices, so we actually have to know what number to type in the box. So when I want to look at these, I'm going to put the left side into Y1 and the right side in Y2. I'm not going to change anything. So if I go ahead, I'm going to hit Math, and the fourth one for the cube root of a 2x minus 5. And then I'm going to put a 3 into Y2. Now, where these two equal each other is where their graphs are going to cross. So if I go ahead and I hit graph, this is where we run into a little bit of a problem. So I can tell that it looks like it's getting pretty close to over here, but it's hard to know if it actually is that exact value. And remember, we're typing this into a box. So one option I have is we could change our window so we can just see more x's, all right? There's not a correct answer for what number you have to type in here. I just doubled it so I can see more. I went to 20, but that's not right or wrong, all right? So if I go ahead, now that I can actually see it a little bit better, I'm going to go second trace, and I'm going to use intersect. And then remember, the nice thing about intersect, which is, again, second trace, and you do the fifth option for intersect, is you can just get as close as you want to. And so I'm going to stop here because I feel like I'm close enough. And you just hit enter 1, 2, 3 times, and it's going to jump over there and it's going to find it. So notice I went to 20, and that's actually a little short because it was at 16. So that was kind of lucky that it was within the 20. And so my answer here that I would write in this box is a 16. Now, let's say another thing you could have done, and this is if you want to check the table, you could just arrow down on this table until you see where the 2y1 equals y2. So if you look right here at the value of 16, you've got your y1 equaling your y2, which is exactly what this problem wanted us to do. All right. Now, this example down here, where I want to find an absolute value equal to 0, something I just want you guys to watch out for, this is actually asking you what are the x-intercepts, right? So there's lots of different ways that the SOL can change the way the questions are phrased. So if I go ahead and I type this into y equals, I'm going to clear this out. And remember what we talked about in the last video. Alpha, all of these little gray buttons up here have lots of fun stuff hiding for us. So alpha y equals is where my fraction bar is. If I go alpha window, notice there's absolute value hiding right there. So I'm going to get used to using that one. But I have a -2 in front first. So -2, alpha window, there's absolute value, 3x minus a 5. Oops, my minus got lost. Minus a 5. And then in y2, I'm going to put 0. So if I go ahead and I hit graph, this one is asking me how many values of x will satisfy this equation. So we're looking at where these two cross. Now, you can't see the line y equals 0, but it did actually draw it in. And I'm just going to drag this over here. The line y equals 0 is actually just the x-axis, if you guys remember that from graphing horizontal lines. So this equation here actually has no solutions. All right, so we would go ahead and we would circle the 0. There's not going to be any x values that satisfy this equation. All right. Now, for a system of equations, we need to know where these two cross. Very similar to what we did here. This is my y1 and this is my y2. So go ahead, I'm going to enter these in and graph them. You do the same. All right, so when I put in my y1 and my y2 and I hit graph, this is the graph I see. Now, these are the points that they're giving me. Now, I can't see the second solution, but I actually know there's another solution up here somewhere. If you want to be able to see all of them, then usually we stick in zoom 6, so I still had my big zoom from the last. So this is what I see here. Now I don't need to see more x's, I actually need to see more y's. I need to move up this way. So if I go ahead and let's just change this, and I'm going to try 20 again just because it might be too small, and you just don't know until you try. So here, if you notice, my 20 was a little bit too small. Now, I'm going to go ahead and you can change your window to 30 if you want. I'm going to narrow in on this little intersection here. So I'm going to go second, calc, to my intersect button, and then I'm going to hit enter 3 times. And if you look, I see a -2, -6. Now, the reason why I stopped searching for the second one is we're actually done. Only one of my answer choices has a -2, -6 as a choice. So I know for a fact that my right answer has to be here. All right. And then this one we would do the exact same way. So we would put y1 here, y2 here, and look for the points of intersection. So again, go ahead and type those into your calculator, 1 for y1, 1 for y2. I'm going to just show you the beginning steps because remember, we don't type any fractions into our calculator without using alpha y equals and getting this nice fraction bar for us. All right. And then arrow over, so we have +2. And then I'm going to type in a 7 over x. Now that one I'm not as concerned with, so I'm just going to keep it like that. And if I go ahead to my graph, let's see what we see. All right. Now, actually, right over here was where they crossed. It was kind of hard to see, so I'm going to go back to zoom 6 again. Here comes the y1, and here comes the y2. This is where the two are crossing, all right? Now, if I go to my table, well, actually, let's just do second calc intersect first. All right, so I'm just going to arrow over and see right here, I can see it. I'm close enough. Hit enter 3 times. And there's my answer. My answer is at 6. All right, so you would actually type a 6 into that box. Now, the next big thing that you're going to have to use your calculator for are your exponential graphs, all right, or your exponential regression equations. So if we go ahead and we look at this, we need to remember where we enter all of this stuff in on our calculator. So if I go ahead and I go to stat, regression is all statistics. We're going to go stat and we're going to enter to edit in our lists. Now, if you need to clear this list out, which on the SOL, you will actually have a cleared list because they're going to clear your calculator. But if you have multiple problems, then you're going to need to clear it by yourself. So you just go up to L1, you hit clear, you hit enter, and it clears it away. All right, so go ahead and enter this data in. Now, with my data entered in, remember we can go stat, and then we're going to go over to calc. Now, this question specifically asks us for the exponential regression equation. Sometimes you're going to have to do quadratic regression. So if I wanted quadratic regression, I would use option 5. But in this one, we want to do exponential regression because that's what the question's asking us to do. So I'm going to go ahead and I'm going to hit enter, 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 and calculate. And there is my answer. So we are going to look and see which one of these matches the closest. So we have about a 23,100, if we round that 62 up to 100, with a 0.85 for our B value. So right here, I can tell that my answer has to be right here, answer C. Okay, now if I go ahead and scroll down, there is the issue that sometimes you actually have to come up with an actual value. So if the radioactive decay continues at the same rate, what is the closest amount remaining after 5 minutes? So they want us to go one step further and come up with this value at the 5. That's a question mark, just a crazy question mark. Okay, so let's again go and put this data in our calculator. So repeat, we're going to go stat, we're going to edit, We're going to clear both of these lists because we don't need all of that data. So we're going to arrow up, hit clear, hit enter, and now take a second to enter in this data. All right, so I've got my data entered, so we're going to go ahead and repeat this. Now this one says it's a radioactive decay problem, which is why I know I'm doing an exponential model again, because that's what exponential models do, is they talk about radioactive decay. So if we go ahead and I'm going to arrow down till I see exponential and hit enter. Now I'm going to show you one last little calculator trick here since I need to do something else with the equation once I get it. So the first one we did, we just were happy with the equation. Now I need to do more. So with that, I'm actually going to go ahead and I'm going to go up here to this alpha and all of these nice little helpful tools up here. And I'm going to hit alpha trace. And look at what it gives me here. It gives me my y vars. So I'm going to go ahead and put y1 there. And then I'm going to hit enter the same way. So the nice thing about this, here is my equation. But we got the equation in the last one the exact same way. The difference is, look at your calculator at y equals now. I'm going to take out this one because we don't need it anymore. It actually stored in this whole equation into y. The reason why we would want to do that is I want to know what's happening at 5. So I can actually use my table now since it's stored in for the y values. So I'm going to go ahead and look, and we should come up with a number that's pretty close to a 14. And there it is, 14.1. Okay. All right, so that's it for this one, and good luck.